Okay, good. All right, so today really is going to be a tutorial on y'all's project. You can see okay? So this is the data file that's on Blackboard. Okay. Now I did add this equation because that's going to help us when we get to this. Now, first thing you want to do is plot the experimental spectrum just to see it. So this is a quick way to plot things. You just do, I'm holding Control Shift and I'm going right arrow and down arrow, and that selects the whole thing. Then you can come up here and insert chart. Now did we talk about all these? Don't ever use the smooth lines, use this one. If we've got lots of data points, we don't want to show the markers. We just want to use the lines only. And so there's our absorbance spectrum for HCl. Now it's down at the bottom, it's at level 1000. So if I try to drag this up, it's going to take forever, okay? So I do Control X, that cuts it. Control X, Control Home, and then Control V pastes it again. And so that moves it to the top. Okay, so this is our HCl spectrum. Now I talked about, well, let's go ahead and make it look like an infrared spectrum. Let's take this horizontal axis. Let's see. Double click this horizontal axis here and come down and do values in reverse order because that's typical for infrared. And then the y-axis crosses at the maximum axis value. So that's good. We can do the axis titles, absorbance, and click down here and do wave number. Okay. If you want to be fancy, you can get in and you can select that -1. Yep, and then you come up to home, and this is font, okay? This little corner here will open up the whole font control box. And so then we hit the superscript. Yeah, so that's nice. Yeah, so that's right. So that's a timestamp 2 minutes. Okay, so there you go. Now these big fat lines I think are ugly. So you come back over here to the paint bucket. We can make them black. You don't have to use color if you, unless there's a reason. Okay, and so I just change the line width to make it thin, so it looks nicer. Yeah, yeah. So that's a nice looking spectrum. We're gonna in our papers and reports, we're gonna put a figure caption, and so we don't necessarily want titles and a figure caption. So we're gonna get rid of this title and we'll use the figure caption to give us what the thing is. Now, Excel automatically puts this outer box. See, there's a little outer box around this. Get rid of that. It's not allowed by this ACS style guide, and so you just do no line there. Okay, and so now that outer box is gone. So when you paste it into Word, it'll be nice and clean. There won't be an extra box around your chart. So we get around that. I'm not talking about this box. This box is okay. This inner box is fine, but it's the outer box. We don't necessarily need the grid lines. Some people like them, some people don't. I'm going to go ahead and delete them, just make it look a nice clean chart. Okay. Why Excel makes the axes gray instead of black, I don't know either. So let's get a little higher contrast on that. Come back over here and do tick marks. This is personal preference. I like to have the major ones cross and the minor ones be on the outside. And so there's our tick marks. Where the tick marks show up, this is the units, the major and minor units. And so you can change those if you wanted it every 50 wave numbers or whatever. Okay. And so let's take the y-axis too, and let's make the colors black as well. So they look a little bit sharper. Okay. All right, so that's our spectrum. Looks beautiful. Now, peak picking. Okay, there's a video online. One of the things that you can do, which I don't recommend, but this is one of the things you can do, is you can zoom in using the axis. Like if we wanted to do the minimum value of 2900, okay, and then the maximum value, this was every 10, so we'll go 2910. There's our two peaks. That's the R0 line, and I could hover over this guy, and I could see 2906.19995, okay? And I've had students in the past write that down on a napkin or something, and then go over here and type it in. And they'll transpose numbers. they'll skip numbers, they'll mess it up. So if you're writing numbers down and then typing them in, that's the wrong way to do it, because you are the weak link here. Okay, and there's no way to copy that number and paste it over there because you're just hovering with the mouse and seeing the number. So don't do it that way. What we want to do is we want to come over here and find the maximum absorbance value and pull the frequency over. So there's a lot of ways to do that. Let me go back here and reset those two limits. So one of the ways is to use conditional formatting. So we can select the whole absorbance range and go to conditional formatting and do color scales. And we want to see the high absorbance value. So let's do the color scale of green is high. And so as we go along, look, our peaks are green. That's cool. So we can see that it's color coded our peaks. And so we can easily find them. Like this is a maximum here, so that'd be the CL35 and the CL37, and that's one of the rotational lines. Okay, so that's pretty neat. The problem with doing the whole range is when you get down to these smaller peaks, there may be peaks here, but because the range, you know, the green peaks are the really tall ones, and now there's not enough sort of colors to color this weak area where there may be peaks. And so what we want to do is not select the whole area for conditional formatting. We want to do it a panel at a time. And so we want to just grab the lines that we can see and do conditional formatting, because now, see, we detect this line and this line, whereas before we couldn't see those. So if you select the whole range, you don't have enough colors, like enough color increments to have the top one be green, and then when you want these little weak peaks, they're not green because you've used green for the really, really tall peaks. So you want to do it in windows. So in this window, we have some peaks. Now, another way to do this too is to put in an if-then statement. So look at this. I'm going to do a flag. So I'm going to call this a flag, and I'm going to say if, let's see, let's do a search of 5 data points. So equals if, open parenthesis, if this cell value is equal to the max of this nearest 5 points. You see what I'm doing here? I'm trying to find the maximum in a range of 5 points, okay? Then I'm going to hit 1. I'm going to return a flag of 1. Otherwise, I'm going to return a flag of nothing, okay? And I'm going to close parentheses. And so I don't get a 1 here, okay? But if I'm scrolling along past this, bing, bing, it finds the max. And I don't have to look in there to say, oh, it's 0.93 and then 0.96 and then 0.94 and all of that stuff. So it's a fast way to flag the peak maxima. And I can check that to make sure it's green as well. So I can double click this and I can go down and I can see all of these places where there's peak maxima. Now I still want to check these with the conditional formatting, because some of these may be false. Okay. So I'm going to do conditional formatting, you know, at least for the weak peaks. I'm going to do a few panels here and there, and then I can do like the full middle range. But it looks like it's picking up peaks, but like this one is not a good one. It's not, you know, we'll see that it's not. So this is a fast way to go through and to find your peaks and to pick them. Okay, so now what do we do when we have a flag? Okay, so we'll do another one that say equals if. So this if-then statements are essentially what I'm doing in my head when I'm picking peaks. So I'm saying if there's a flag, okay, if this equals 1, then go get that value, okay? Otherwise, just return nothing. So it's two quotes with nothing in the middle. So just return nothing. And so there's my peak. Now I also want to do the same thing for the absorbance value. So I'm going to look at that flag, and if the flag is 1, I'm also going to pull the absorbance value over there. So now I have the frequency and I have the intensity for each of my peaks.
What was the if parameter that you put in there? Because you were showing how some of the ones that are red still show a 1. So
Yeah.
what was that parameter that you put so that you would only get
The maximum, okay, this one, the maximum formula? Yeah, it's max, and I'm just using a range of 5. So in between the peaks, there might be a little noise peak, and it might pick a noise peak in between my R lines and my P lines. And so we'll just look at the trend and we'll throw those away. But it's easier to throw some of those away than it is to go through and try to figure out where the peak maximum is, 0.93, 0.96, 0.94, 0.91. You know, that takes a long time. You may not think it does, but when you have 100 lines to pick, you need to find a way to do it faster. And this is just a way to do it faster. Okay, so we have these. These are going to pick all of our flags and give us all our transitions and intensities, even when there's no colors associated with it. But we'll go ahead and put the colors on these. Okay. So I'll go down, I'll do the colors this far, and then I'll start another panel for the color. Okay. So you see, I'm not being too picky with my color panels. I'm just going a little ways and doing the formatting just so that it breaks it up into different ranges of red to green. Okay, I'll just finish it out here because you get the idea, right? All right. So now we're going to go through and we're going to get rid of some of these false flags. Like, see, this one is clearly a peak, 0.8. Okay, this one, it didn't pick this one up, but it should have. So I'm going to go ahead and put a 1 there just manually. But like this one, I'm going to delete. This one's not a peak, right? There's no real reason. You can kind of see, well, that's a bad patch. Let's go up here. Let's see. Yeah, so here we clearly see some green lines here, and some more green ones. We're picking up a lot of noise peaks, so we're just going to delete these. So if it doesn't have the two lines right here, those two green lines, if you wanted to just check your work, let's look at this. We're just going to, I'll just have to prove to you, I guess, that what is a good line and what is not. Okay, so look at the region I'm plotting. I'm plotting just that region. Insert, plot. See, I've got 2 peaks. All those other little lines in this plotted region are noise. So I'm just going to delete them.
you would take those 2 peaks though?
Yeah, I would take those 2 peaks, but I would delete these guys. These are coming in as noise. And these I would keep. These right here are the, see, almost 0.5. Here's 0.48. So that's the big one. Here's the 0.32, 0.32. So these are those 2 peaks right there. And so these are noise, these are noise, these are noise. Okay, and here we've got 2 more good ones. So I'm keeping those. These are noise, these are noise. And if you wanted to check, you can always plot it. You know, let's just check just to show you again, if I wanted to check if this one's real, we can come here and quickly look at the plot. See, I've got 2 peaks here. That's the 0.28 right here. This one is close to 0.2, so 0.196. And so then this guy up here is noise. It's this little barely, hump. So we can delete that. Now I could probably come up with some, threshold or something to make this cleaner, but it's fast enough. It saves me some time. And so again, these are all in between 2 lines, and so I'm going to delete those. Okay. Here's two more. And then here's the next one. And so I'm going to delete all of the ones in this region. Okay.
So ones that are in the kind of red region, we can
Yeah,
automatically.
you can just delete, yeah. And that's if you've done lots of little panels, okay? Because then the red ones truly are noise, yeah. Okay, and so this I found was a lot easier on my brain because I'm not really using a lot of mental activity to delete these. I'm just looking there in the red region, between lines, I can get rid of them. I'm not having to scrutinize 0.13 and 0.14 and 0.12 to try to find the maximum. Okay. It's still a bit tedious, but it's a lot less tedious than hovering the mouse over the plot. See, here's two right there. Those are legit because you see the drastic change in color, right? And again, you might come up with a better trick, an better if then statement to get those. Okay, so let's go to the top, Control Home. Now these are the ones I want to keep. So frequency and intensity or absorbance. Now I'm going to grab those all and I'm going to pull them off. I'm not going to sort this column because I've got my if then statements and all of that stuff. So I'm just going to grab these here. I'm going to do Control Shift down, and since there's formulas in all those cells, it gets everything. I'm going to hit copy, and then I'm going to come over here and I'm going to paste them right here in my data assignments spot. Okay. So I'm going to paste them as values. Okay. And then I'm going to sort them. Data, sort A to Z or low to high. So I want, actually, I think one low to high. Okay. And so here they all are, sorted low to high. It treated that top value as a data label, actually. I put this first line in here just for you guys to have an example of what to start with, but we don't really need that one. You can see this is the 3097.6 peak, and so we can just delete that guy. When you delete, oops, I didn't mean to do that. When you delete cells, and it shifts the cells up, okay, like that. So it deletes, and there we go. Now, one thing I would like to do is to detect when we have, some false values, some of those ones that don't have a good. So I'm going to say, let's take the difference equals. Let me resort. Okay. Okay, I just want the data. So I'm going to grab that and I'm going to sort. We can do low to high again. Okay. And it keeps picking up that 3097 as a data label. Okay. Sort low to high. Yeah, there we go. All right, I want to take the difference between all of these to see if we have a uniform difference. The uniform difference should be 2 times the rotational constant, right? These are Rovibrational lines. There'll be some small differences because of the HL 3537, so they should alternate. Big difference, tiny difference, big difference, tiny difference. So let's see what we get. Yes? 3097. It was, whenever I was hitting sort, it was dropping down, treating it as a header. Yeah, and so I was fighting with that. Yeah, it was treating it as a header, so I had to sort it like 3 times to get it to not do that. Eventually, I had to select frequency and absorbance as headers and select the data. And then when I was using control down, it was going down and getting all of those double quotes too, and I didn't want those. I just wanted the numbers. So I also had to fight a little bit with just to get the numbers to sort. Yeah.
But that'll be in the video. So
Yeah, that's right. Yeah, so here, but I wanted to narrate why I was having so much trouble. So that's why I was having so much trouble. So I'm going to take the difference here, and I'm going to copy that down just to kind of see the differences in all of these values. Okay. All right, and so now we're going to shrink those just so we have less to process in our brains. We see, a uniform difference here. This is the difference between two isotopes, and this is the difference between two rotational lines. And we immediately see a pattern, don't we? We see an isotope difference, rotational line difference. So like the difference between two R lines or P lines, okay? And so look in this region, we start to see a kind of a mess. So a lot of these right here are bad. Yeah. Yeah, so we've got a lot of lines that are still in this red region. So maybe we should go back and clean that up. Like this one, we're getting too many of these right here. So we want to delete this, we want to delete that. Let's spend some more time cleaning this up. Because we should see a nice pattern. See, you have this difference here, and then you have the difference between this line and that one. And then you have a small difference, and then, a big difference. And what we're seeing is all of this noise. So we're going to get rid of these guys, spend a little more time getting rid of these false flags. Those are good because they're green. You see, they're kind of green. Get rid of that one. These are too close, like adjacent to each other. That's not good. Okay, this is false here. So just clean out all of this noise, and then your assignment will be, your peak picking will be done. Notice, even though this is tedious, how much control we have over which peaks are picked. There's a software called Spectroscopy, which I'm going to talk to you about in a second. Hopefully I can manage my time and get to it. It does peak picking for you, but you have no control over what peaks are picked. You have very little control, I would say. Not zero, but it's not like this.
Are you just deleting the if statement? Is that how you're, okay.
Yeah, and so once the ones disappear, then the criterion fails for copying those things over. So I'm saying if it's a 1, copy over the frequency and the intensity, but if it's not a 1, then don't. And so this is, like I said, it's tedious, but it's worth it because in the end you'll be done. And this is pretty fast. See, I'm just scrolling down. I'm not seeing any more. I think this is the area we cleaned up before. Okay, so I think we have it all. We don't have any noise peaks anymore. So let's go back to the top. Let's recopy these things. Come over here and we'll paste them right here. Paste values. I don't know how to get it to not paste those little sort of text blanks. I'm sure there's a way to do it. So I'm going to go to data, sort, low to high, and it did it just fine that time. And so now we see our pattern. You see the pattern? 22 and 1, 22 and 1. It goes down all the way. Here we have a big gap. Okay, that's probably our Q branch. Okay, we'll have to check that. You see, it's no longer quite 20, but it's still sort of a pattern, a consistent pattern. I'm going to go ahead and take all of these guys right here and delete them all the way down, and that'll clean all that. Okay, so there's our peak frequencies and intensities. Okay, now we can plot these things. We can figure out what isotope they are and all of that. But let's go to the middle of the spectrum and start with the R0 line. So let's find that R0 line. It's real close to 2900. So it should be around 2904. That makes sense? So let's start with R0, 2904. So we go down here to 2904. Okay. And it should have the R line, the 35 isotope should have the tallest frequency. I mean, the tallest absorbance. So we have 2904 and 2906. Okay, so those two are together, and so that's going to be R0. Second, let me go up here and I'm going to do freeze frames. Okay. Do y'all know about freezing the panes? So I'm going to freeze these panes right here, freeze panes, so that when I scroll down, you see the isotope and branch stay put. So I'm going to scroll down here to 2904, 2906, that range. Okay. And this is the isotope. This is the taller one, the 2906. And so that's going to be the 35. And the shorter one's the 37. Is everybody okay with that? 35 is the most abundant chlorine, 37. So the most abundant would be the taller of that pair. This is an R branch line. Both of these are R branch transitions, and they're both zeros. Does that make sense? And so then we have that same repeating pattern, 35, 37. Oh, that didn't work. We'll have to do it by hand. Okay. This is R. R. We're going up in value, so this is going to be the R1. So you see we're assigning the quantum numbers, the R branch, and the isotopes to all of these lines. And that's all you got to do to assign your spectrum. So we take this same pattern, copy it, go all the way down, paste it. Okay. R all the way down. This equals that one. So I'm skipping one, plus one. So then this will go all the way down. Oops. There we go. So there I've done the R branch. Now we go across that 39 wave number gap and we get into the P branch. Again, still the 48 would be the 35 isotope, and the 31 here would be the 37. So we're going to go ahead and copy those up. That's weird. Why is it doing it that way? Okay, Excel's being funny to me. I don't know why it won't let me paste all of them. Oh, because there's an odd number. Do we have a noise peak in there somewhere? Oh, up here. That's why. I just didn't scroll up far enough. Okay, there we go. And these are all P branches. Yes. Any question? Yeah, because there's nothing above it. Yeah, yeah, that's fine. And then, so then this is, what's the first P value? The first P line, like the designation, the J value for the first P transition. We don't have negative rotational quantum numbers. So that's why we can't have a P0. Yeah, that's okay. You remember stuff that you miss, right? That's right. So if you started at P0, then the upper J value would have to be -1. And we can't have a negative J value. So we have a P1 line, and the upper value is 0. So we're starting at J equals 1 in the lower vibrational state and going to J equals 0 in the upper vibrational state. So this is 1, and so is this one because the two isotopes. And then it's 2 and 2 and so on. So I'm going to say this equals the 1, 2 below it plus 1, and I'm going to copy it up. Okay. So there's the 3, the 4, the 5, the 6, and so on. Now let's see how we did. Okay, how do we do that? Well, I want to plot the frequency on the y-axis and the J value on the x-axis because I want to see if if I've made for some reason some mistake or I skipped a line or something like that. So we should see nice trends with our P and our our R branch lines. Now, this seems really dumb what I'm about to do, okay? But I found it's faster because look at my J values. They're way over on the right and my frequencies are way over on the left. And for Excel, it wants the x-axis to be on the left and the y-axis to be on the right, okay? So I'm just going to give Excel what it wants. I'm just going to plot frequency versus absorbance, okay? And then I'm going to move things around, okay? So insert chart. Now I'm going to use this one here with the line and the, so here's my transitions. Actually, I don't really need the line. Let's do line, no line. Okay. But I don't want absorbance actually. I want the X values for this to be my J values. So I'm going to click on the series here and I'm going to just grab this purple region and I'm going to move it over to J. Okay. And then I'm going to move the absorbance, the Y values over to frequency. Okay. So I just made a plot of something I didn't care about and then swapped the X and the Y values and it was faster, I think, than doing it. So this is looking great. Notice I don't have any missing dots. Like if I'd have skipped a pair, there'd be a gap, you know, or it would be a jump actually. I show in the handout what it looks like if you make a mistake. If you miss a line or you double assign a line or you just type something in wrong, you wouldn't see this very smooth thing. So this tells me we've assigned our frequencies in a good way. Okay, so that's a sort of an intermediate plot. You don't have to turn that in, but it is a nice thing that comforts you when you make an assignment. You should see a nice smooth plot like that. Now we're ready to make our regression. So I'm going to come back up here to view and I'm going to unfreeze my panes. So that's on the home tab. No, it's on the view tab. Oh, here we go. View tab, unfreeze panes. So I can scroll up. So here's my equation that I'm going to do the regression on. And it uses this M quantum number, okay? So I've got to assign M values. So do you remember from the notes what the M value is for the P branch? You have your notes in front of you? You're looking down. No. Because we've got two trends here. We could do trend lines on these data, but we have then two answers. We have a bond length for the P branch and a bond length for the R branch, and that's no good because we have one molecule. Okay, so we want to combine the P and R branches. So we want to fold that P branch over to negative quantum numbers. Well, that makes sense, right? So M should be minus J. So for the P branch only, M is equal to minus J. So that's minus 11 for the P11 line. And I'm going to go down, but I'm going to stop at P1. So there's my M values for the P branch. Now for the R branch, oh, let me get one more. For the R branch, M is what? It's not just J, because we don't want the M to be 0 for one of the branch lines. Yeah, J plus 1. J plus 1. And so now the R0 has an M value of 1. So there's our M values for the R branch and our M values for the P branch. And you see right where we have this big gap right there, that's where the M goes through 0. And we're missing the M equals 0 because that would be the Q branch. Okay, so this is great. Okay, I'm going to scoot this over. And now we're going to make our regression columns. You see the coefficients are what we want. We want nu 0, we want BE, we want alpha E, and we want DE. Okay, and so when we do a regression, we want those to be a coefficient of our columns. And so we have to make columns that correspond to what's in parentheses here. So this is a 2M column. Let me put the formula up above, like 2M. And right here I'm going to say BE, because that's the BE column. Does everybody agree with that? Okay. Then this one I'm going to do minus 2M minus M squared. Oh, I did N, sorry. M minus m squared. Oh, it thinks I'm putting in a formula. Okay, so it says that's 0. So sometimes if you want to start with with a minus sign like that, and it doesn't know what m is, you have to put an apostrophe. I'm going to do apostrophe minus 2m minus m squared, and then it knows I'm putting in text. So that's a nice little pro tip there. If you wanted to make this square, you could go in and highlight the 2 and do the font and the superscript. That's not required, but it is pretty. Okay, so there's that, and this is alpha E. I could go ahead and do the symbol font and find the alpha and make it a subscript, but we don't have time for that right now. Ain't nobody got time for that. So plus 4m. Oh, I got to do my apostrophe. Okay. Minus 4m cubed. 4m cubed. Okay. And this is DE. So do you see our 3 columns? Yeah. I'm going to make those all centered just for beauty's sake. So then now you've got your 3 columns that you want to make, so now just make them. So this is equal to 2 times m. So equals 2 times, and don't type in m like I do, because you got to click the cell. So m is the cell there. So that's minus 22. Double click the corner, and you got it. And then this one is equal to minus 2 times the m value minus the m value squared. Okay. If you do this the other way, sometimes Excel makes some mistakes. Like if you start with minus m squared minus 2m, you'll get positive values sometimes, because it'll put the minus m in, it'll square both. It'll like minus m first and then square it. And so I found it works more reliably if you do the square or the cube last. Okay, and then minus 4 plus 4 times m. Be sure you click the right cell. Minus 4 times m raised to the 3rd power. Okay. Okay, so there's all of our columns. Now it still remembers these text fields that are buried in my deal, so we'll get rid of that. Okay, so we've done the assignment table. We now have our 3 regression columns, and it's time to do the linear regression. So this is on the data ribbon up here. These are called your different ribbons. And over here is the data analysis feature. If you don't have that, go through the notes. You come to File, you do Options, you do Add-ins. Come on, computer. Add-ins. Down here, Excel add-ins. Let's see. Yeah, Excel add-ins, go. And then you click Analysis Tool Pack, and go ahead and get Solver, because we're going to use Solver in this course too. All right, so we have the data analysis. We click it. All these options that you have, come down to regression and hit OK. Now, Y range. These are our frequencies, because this whole equation up here gives us our transition frequency. And so that's the dependent variable is our frequencies. So I'm going to include the label. So I'm going to do Control-Shift down. Why is it not doing it? Of course, Excel would not cooperate on days when I need it to cooperate. So we're going to have to do it just by dragging. So we're going to just drag the whole thing right there. Okay, that's the Y range. And so then we go back up for the X range. And I'm going to get the labels, the BE label, alpha E label, and the DE label. Okay. And I'm going to click this checkbox labels. Okay, so that's telling me the first row are the labels. New worksheet ply, that's a good thing to create a new worksheet. I'm going to call it Reg 1 or whatever you want to call it. Oh, we've got a problem because we've got both isotopes in here. So we would want to sort by isotope and do a 37 isotope and a 35 isotope. So let's bail out of that.
Should we make
You could, yeah. In fact, you could take this and if you wanted to like just control drag this over and then delete all the 35s and then control drag it over again and delete all the 37s. That's a real quick way to make your two tables. So we can call this one 35, H35CL. We're just going to grab this whole table. Right here, and we're going to tab over till we get to the isotope, and we're going to do sort. Okay, and now the 35s are on top and the 37s are on bottom. And so we can, we can go, oops, down and delete. So there's our 35 assignment table. Now let's do the data analysis. Regression, Y range with the frequencies. Okay. Dependent variable, get the BE, DE labels. Click labels. Let's call it regression 35 on a new worksheet ply, okay? And we'll hit go. And here's our summary output. Okay, great. Doesn't look good at all. So what is it about this that doesn't look good? Well, the R squared should be way better than that. Okay. Look at the standard error in our vibrational frequency. So this is new 0. And these are our p-values, and this is saying the centrifugal distortion constant's not statistically significant. So something's wrong. Gotta be. Yeah, because then when you leave labels on, like it put these three right there, instead of saying x variable 1. If you don't have the labels, it'll just call it x variable 1, x variable 2, x variable 3, and those are your 3 columns. And the intercept would be, from your equation, your intercept would be this value right here. That's the intercept, right? It has no m value beside it. So your intercept is this one. This would be x variable 1 because that's column 1 and so on and so on. Okay. So, did our frequencies, isotopes, 0, yeah. Okay, so looks like we've done everything.
Oh, okay.
Yeah, so the J values are all messed up. Okay. Because this is still a formula. I didn't, yeah, so, okay, so let's do this. This is 1, it was because I put formulas in for my J value. So this is P1, okay, it's not a formula, so I can rely on that. P1, and then this was 2, this should be 3, and so it was the formula that I did. See, all of these are doubled, and so what we're gonna do is we're just gonna make sure that we don't have the wrong J values. So this is equal to the one below it plus 1. So that's P4 all the way up to P11. And that I remember that from an earlier table. So it was because I had formulas in these values. So this is R0, R1, and this should be equals this one plus 1. And that'll go all the way down. Okay, got it. So see, now our plot looks very nice, and that's what we should expect. If you want to get rid of those formulas, you select the whole column where those formulas are, and then you just quickly copy and paste values, and now you just have values in their formulas. Okay. So let's redo the regression. I'm actually glad that happened because we could see what a bad regression looks like. This is a crummy R squared for this kind of analysis. We should have 4 9s at least, and sometimes 6 and 7 9s. Also, look at the standard error. This is 4 wave numbers of standard error. If we were to let the standard error tell us where to round, this is what our vibrational frequency would look like. This is what our rotational constant would look like, right? So our standard error and the coefficient should be rounded to the same place value, okay? Whether it be tenths, hundredths, or whatever. look at our alpha E. So this is really good that we had this glitch. Okay, so that would be our alpha E value, and this would be our DE value. And our DE value is not statistically significant. This P value, well, it is, but it's not as great as the other ones. Okay. Okay, dang it, we're out of time. So we'll do the regression and we'll have a nice happy ending. Okay. So we go to the data tab, data analysis, go to the regression. It should have the same things that's already selected, frequencies, yeah, that's all good. We're going to call this reg 35 2. Okay, so we can compare the two. Yeah, that's what you're looking for. See, the R squared value, way, way better. And then look at these. Let's do our little rounding experiment or like illustration. See, now we have to hundredths places in our vibrational frequency. We have to the thousandths place in the rotational constant. This one here is to the 10,000ths, and our centrifugal distortion is into the, what is that, 100,000ths or millionths. Okay, and also the p-values have dramatically improved. Okay, so that's the difference between a good regression and a bad regression. Okay, and so as soon as I saw this bad regression, I knew, okay, there's something wrong with my table. And I'm so glad we were able to find it, because it would be a really terrible video to go through all of this and say, something's wrong, but I don't know what it is. Right? So we went in and we found that problem. Okay. So that's our regression. Now we know these values, and then we can use BE to come up with the bond length. And we can use the vibrational frequency to come up with the force constant. And so those are derived values. So these come straight from the regression, and then we derive the force constant from the frequency, and we derive the bond length from the rotational constant. And we'll pick up on that on Friday. And then on Friday, we'll talk about the propagation of uncertainty for those two. Yes? Mm-hmm. Yes. So I wanted the assignment, the like Tuesday night or Wednesday night. No, it was the Tuesday night due date for like the Excel and the PowerPoint. So I know that you're done with it. But then the written report is later. So like after your presentations talking about it, you still have some time to write it up.
It's something you do on Sunday.
Okay, I'll check on that. Yeah. Okay. You have enough information to do the quiz. Like just from the lecture, you have enough information to do the quiz. Yeah. Yeah. This is all related to the project and actually you doing your own hands-on regression and stuff like that. Yeah. Yeah, but my goal, so I'll iron out if there are errors in that, but my goal is to have an earlier due date for the spreadsheet and for a PowerPoint if we're doing it in class like we've been doing, which we will, and then having the written report be later so that you have time to do the writing. Okay, so that's why there will be 2 due dates for the projects. There will actually be 3 things you submit. There'll be a link for the Excel sheet. There'll be a link for the PowerPoint, and then there'll be a separate Turnitin link for the written part. So there will be 3 due dates for the project, or 2 due dates and 3 things to turn in. Yeah, that's the latest one. Yeah, so that's the latest due date would be the Sunday. Okay. Um, yeah, yeah. Okay. Well, I'll look into it. But yeah. This Sunday's not the big written report though. Okay. Okay. All right. All right. I'll look into it. Okay. No, I'm not sure. I'll look into it. Okay. Yeah. Yeah. Okay. That's she's laughing. Yeah. She's like, yeah, yeah, that's right. Yeah, that's right.